Okay, on number 3, it says that it wants us to go ahead and find the integral from 2 to 6 of 8 dx. So the very first thing you want to do is you want to go ahead and find your widths. So remember, to find your widths, you're going to go ahead and take this number right here, subtract this number. And so we got 6 minus 2, and then we're going to divide it by n number of rectangles. So this is going to be our widths. And so when we take 6 minus 2 divided by n, you get 4n. And so that part of our equation is right here, which is 4n. Now to find your lengths, you're going to go ahead and take this equation right here. You're going to put an I with it, so you got 4i all over n. And then we have to take this number right here and add it to it. It's got 2 plus 4i over n. So all of our lengths is going to be f of 2 plus 4i all over n. So remember, your formula is the limit as n approaches infinity of f of delta x sub I all times delta x sub I. So these are our lengths and this is our widths. So substituting this in, so here's my lengths right here, here's my widths. So here I'm taking it to infinity, and I've got I equals 1 to n of f of 2 plus 4i all over n. Okay, now to solve this, so we're going to go ahead and scroll down up here just a little bit. Okay, so now to solve it, so here's my 4 over n, which is a constant. It's going to go out front. And now remember, this equation right here is going to be substituted into the original equation. So when I substitute it into the original equation right here, so this 2 plus 4i all over n is going to go into this equation 8. And notice there's no variable right here. So since there's no variable right there, when I substitute in, I'm just going to be left with the summation of I equals 1 to n of 8. And when I do that, my rule for summation notation, you just take this times this. When I take that times that, I get 8 times n. Okay, I multiply this together, and I'm going to get 32n all over n. And when I take that to infinity, remember, I'm just finding those horizontal asymptotes. And so the power is the same. So that just means I take the leading coefficient over leading coefficient, and my answer is going to be 32. Okay, when I look at this next one on number 5, I've got the summation of negative 1 to 1 of x cubed dx. So first, again, I'm going to find my widths. So to find my widths, I'm going to take these two numbers, subtract each other, and put that all over n. And so 1 minus a minus 1 is going to be 2, so I get 2 all over n for my widths. So now to find my lengths, and I'll just substitute it right in the formula right here. So here's my widths right here. So my lengths, I take this 2 over n, I put an I with it, and then I put that negative 1 right there. So that's negative 1 plus 2i all over n. And remember, to find those lengths, you got to substitute into the equation. So that's f of that. So when I substitute this in, so notice this is my constant. 2 over n is my constant. So here's this right here. This should be a negative. Apologize for that negative. 1 plus 2i all over n, substitute into here. So that's all going to be cubed. Okay, now that I've done that, I just need to cube that out. So the way I'm going to cube this one out is I'm going to use my Pascal's triangle. So if you remember Pascal's triangle, because I don't want to multiply 1 plus 2i over n times 1 plus 2i over n plus, or times 1 plus 2i over n, because that's kind of long. So remember, right, Pascal's triangle, you've got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So I'm just going to use those coefficients. Where's my 1, 3, 3, 1 coefficients that I'm using right here. And if you remember right, your first term descends. So here's a negative 1. It's going to go down, so it's negative 1 to the third, negative 1 to the second, negative 1 to the first, and negative 1 to the 0. And then my last term is going to ascend. So 2i over n to the 0, 2i all over n to the first, 2i all over n to the second, and 2i all over n to the third. Okay, now that I've done that, I'm going to go ahead and multiply this all out. So of course, negative 1 cubed is just going to be negative 1. This to the 0 is going to be 1, and the 1 times that is just going to be, so this leads to negative 1. Okay, so now I've got -1 squared is going to be +1. I've got 2i all over n to the first, so that's just going to be 2i. When I multiply this by that 3, I get the 6i, and that's still all over n. Okay, when I multiply this by this next one, so here I've got -1. This is going to be all to the second power, or sorry, to the third power. So when I multiply that out, that's going to be that negative. So when I multiply that out, I get the 2i squared is going to be 4, and 4 times 3 is going to be 12. Okay, and so that's going to give me that -12i all over n squared. And then, looks like this is a little bit off now. Okay, now looking at this one right here. So now I've got the -1 to the first. 2 squared is 4. 4 times 3 is 12. So you've got -12i all over n squared. And then on this last one right here, looks like I've got -1 to the 0 is 1. So here's my 2. This didn't come out very well, but 2 cubed is going to be 8. So I've got 8i cubed. And then my n to the third is also going to be n cubed. Okay, now that I've done all that, notice this right here, this is going to apply to this. And so I kind of already applied it. So that's going to become -n. And here is my 6 over n is my power. So my I, here's my formula, n times n plus 1 all over 2. So notice here's my -12 all over n squared. That's going to be my constant. And then here's my I squared formula. So that's n times n plus 1 times 2n plus 1. And then that's all over 6. And then here's my constant again, my 8 over n cubed. And here's my I cubed formula, n squared times n plus 1 squared all over 4. Okay, now that I've done that, I'm going to take this to infinity. So notice when I distribute this on through, that's -2n all over n. And then this also distributes to this next one. So that's 2 times 6 times n times n. So remember, I'm just doing first now. I'm not multiplying it all out. So that's 12n squared. And then I've got n times 2, which is going to be 2n squared. And then I'm going to apply that to this one right here. So applying that to this one right here. So I've got 2 over n. And apply that to this one. And so notice this comes out to be 2 times -12 times n times 2. So that comes out to be -48. And the n's give me n cubed. And then I've got this n times 6n squared is going to be 6n cubed. And then I'm going to apply it to this last one. So I've got this 2 over n and multiplying it by my last one. So I've got 2 times 8 times n squared. So that's going to be 16n to the fourth. So here's an 8n. This n is going to be squared. Here's my 2. And then this n times n cubed times 4 is going to be 4n to the fourth. So those are all my first, and I'm going to take them to infinity. So when I take this to infinity, notice -2 over n all over n, power is the same, so that's -2. Power is the same, so that's going to be 6. Power is the same, so that's going to be -8. Power is the same, so that's going to be 4. I add all those together, my answer is 0. Okay, on number 7, again, these two numbers right here, find your widths. So 2 minus 1 all over n is 1 over n. Okay, this number right here has to be added to that, and then you put the I with that. So that I is going to go right there. So those are all my lengths. Substitute into your formula. So when you substitute into your formula, notice here's your widths, here's your lengths, and that's going to the F equation. So I got to substitute that into that x squared right there. And so when I do that, I end up with my formula. So 1 plus I over n squared. Here's my plus 1. And this 1 over n is a constant, so it goes out front. And that's the limit as n approaches infinity of 1 over n times the summation of I equals 1 to n of 1 plus I over n squared plus 1. Now when you FOIL this out, so first outside, inside, last. So notice again, here's my constant. So first, it's going to be 1 times 1, which is 1. Outsides is in, insides is in. When I add those together, I get 2i all over n. And then my last, which is just right here, is going to be I squared all over n squared. And I still have my plus 1. Combining like terms, 1 plus 1, that's going to give me that 2. And notice here's my 2 over n, so I put that out front. I still have my I in there. I separate it out. And then this also, the I squared over n squared. So the 1 over n squared goes out front, and my I squared stays right here. Okay, now I'm going to go ahead and use my summation formula. So remember, this times this, that's 2n. You still have your 2n right here. Your I form is n times n plus 1 all over 2. And you have 1 over n squared. And then your I squared form is n times n plus 1 times 2n plus 1 all over 6. Now just looking at the firsts. So here's 2n over n, distributing that on through. And then I'll distribute to this one. And remember, I'm just looking at that first term. So this will be 1 times 2 times n times n. That gives me 2n squared. So that's n times 2. So that's 2n squared. So just doing the first. So I've got 1 times n times 2. So that's going to be 2n cubed. I've got n times n squared times 6 is going to be 6n cubed. Okay, now taking these to infinity, power is the same, so that's a 2. That's both those are the same, so that's going to reduce down to 1. Power is the same, so that becomes 2 6, which is 1/3. 2 plus 1 plus 1/3 is 3 1/3. 3 1/3 is 10 thirds.